All right, so we've been dealing with square roots. Now we're going to deal with functions or equations that have an x squared in them, and those are called quadratic functions. So a quadratic function is a function that can be written in the standard form of y equals a times x to the second power plus b to the b times x plus c. So having the square right there, x squared, is what makes this a quadratic function. So when we deal with these, we can graph a quadratic function, and when we graph that quadratic function, it's going to be a U-shaped graph that we call a parabola. So if you hear somebody talking about a parabola, that's just the graph of a quadratic function. Now, if the leading coefficient is positive, the graph opens up. So leading coefficient, we're looking at the a in front of the x squared. Whatever number is in front of the x squared is our leading coefficient. So if that's a positive number, our graph's going to open upward. If that leading coefficient is a negative number, our graph's going to open downward. So now the vertex is going to be the lowest point on the graph that opens up, or the highest point on the graph that opens down. So if our graph's opening up, vertex is going to be at the very bottom. If it's opening down, then it's going to be the highest point in that graph. And the x-coordinate of that vertex, so if we're trying to figure out where that vertex is, we know the x is going to be the point negative b over 2a. So our x value at the vertex is going to be the b value, the term in front of the x, the negative version of that, over 2 times whatever our coefficient is in front of the x squared. And likewise, the axis of symmetry is going to be the line, or the vertical line, x equals negative b over 2a. Right? Axis of symmetry means that there's a line that's going to go through our graph that we could fold the graph on that line, and both sides are going to match up perfectly. So this is a symmetrical graph. Whatever is on the left side of the axis of symmetry is going to mirror what's on the right side, and vice versa. So if we're going to graph a quadratic function, first thing we're going to do is figure out what the x-coordinate is of the vertex, which when we do that, that's going to tell us where the axis of symmetry is, and it's also going to give us a starting point of where we need to start with our x values to plug in to find our y values. We're going to then make a table of values using the vertex and 2 x values to the right of the vertex. We might need 2 values to the right will give us a basic idea of the graph, but sometimes it might be useful to go ahead and do 3 just to get a little bit better idea of how that graph is going to expand. All right, then we're going to plot the points. So we've got the vertex point and then 2 points to the right. We plot those, and then we're going to mirror those points that are on the right of the vertex on the left side of the vertex. All right, and then we connect the points with a smooth curve to form the parabola, and we've got the graph. So this is kind of a complicated process, especially if you think about when we graphed linear functions, just a y equals mx plus b. This is a little bit more difficult than that. So our first equation, y equals x squared plus 3x minus 4. All right, there's nothing in front of the x squared, so we're going to assume that's a 1. Right, and then there's not a negative, so that's a positive. And since that number is positive, we know that this graph is going to open up. Right, so it's going to look like a real U. The opening is going to be at the top, which we look at that just to give us an idea to make sure that we are graphing it right when we start graphing it. Now from here, we need to identify what our A is, which we said is going to be 1. B, which is always in front of the x term, is going to be 3. And we need those in order to find the x-coordinate of the vertex. And so the x-coordinate of the vertex, remember, is negative b over 2a. So that's going to be negative 3 over 2 times 1, or negative 3 over 2, which also tells us that the axis of symmetry is the line x equals negative 3 halves. So when I look at my coordinate plane here, I know that at negative 3 halves, which is the same thing as negative 1.5, right, my vertex is somewhere on that vertical line, which that vertical line is the axis of symmetry. If I could spell right here. So the axis of symmetry is there at negative 3 halves. So whatever we do on the right side of that, we can mirror that on the left side to make our full graph, which also allows us to not have to graph quite as many points. So once we've got that, we're going to make our table of values. And just a little note here, when you're doing the homework or the assignment that goes with this section, I'm giving you multiple choice assignments for you to plug in the values for those A, B, C, or D into that answer form. But when you turn in your work, I need to be able to see the points that you made, or I need to see the work of you creating this table in order for you to get credit for that assignment. So you need to make a table like this for every problem that you graph on the assignment. So we got x squared plus 3x minus 4. When we do all that work, we're going to spit out a y value to go with the x values. So the first x value we're using is negative 3 halves. That's our vertex. And so plugging that in, we're going to have negative 3 halves squared plus 3 times negative 3 halves minus 4. Negative 3 halves squared is going to become positive 9/4. 3 times negative 3 halves is going to be negative 9 halves. And 4 is just sitting there by itself. Now, in order to add or subtract with fractions, we got to have a common denominator. So 4 is the biggest denominator, so we're going to make everything have a 4 for the denominator. So it's going to give us 9/4 minus, in order to get a 4 at the bottom here, we have to multiply everything by 2. So that's going to be 18/4. And that 4 is over 1. So to make it a 4 on the bottom, we've got to multiply everything by 4. So that's going to be minus 16/4. 9 minus 18 is going to be negative 9. Negative 9 minus 16 is going to be negative 25 over 4, or negative 6 1/4, or negative 6.25. So on this axis of symmetry, at negative 6 1/4, so just a little bit below the line for negative 6, right there is our vertex. That should be the lowest point on this graph since it opens up. Now, we're going to plot some points to the right of that. And we could use the negative 1 there. I'm going to go ahead and skip it because it's only half of a increment over. So I'm going to go 0. And I'm going to also use positive 1. So with that, I'm going to have 0 squared plus 3 times 0 minus 4. So all that's going to become 0 and just leave us with negative 4. So at 0 on the x, we're at negative 4 on the y. And then if I go one more step over to positive 1, it's going to be 1 squared plus 3 times 1 minus 4. 1 squared is 1. 3 times 1 is 3. So 1 plus 3 is 4 minus 4. It's going to give us 0. So 1, we're at 0. So now remember, that's only half the graph because this is the axis of symmetry. So there's a part of the graph over on this side. And to get those points, we're just going to mirror the points that we did to the right. So this point is 1.5 to the right. So we're going to go 1.5 to the left. The mirror point goes there. This point is 1.5, 2.5 to the right. So 1/2, 1.5, 2.5 to the left. So there's our points. Then we join those with a nice smooth curve that goes through all our points. And there will be our parabola, or the graph of x squared plus 3x minus 4. So next one, y equals negative 1/2 x squared minus x plus 1. So same process. First we look here, that's negative. So now it's going to open down. So it's going to be like this graph, but flipped over. So it's upside down. And so we need to recognize what a and b are. The a is what's in front of the x squared, so negative 1/2. B is what's in front of the x, which there's no number there, there's a negative, so we would assume that's a 1 in front of the x, so negative 1 is going to be our b. So the x coordinate of the vertex is negative b over 2a. So our b is negative 1. So negative times negative 1 over 2 times a, which is negative 1/2. So negative 1 is going to be positive 1, and 2 times negative 1/2 be negative 1. So we end up with negative 1 for that x value. And also the axis of symmetry is going to be the equation x equals negative 1. So that means right here on negative 1, there's our axis of symmetry. So our vertex is going to be somewhere on that line. Make our table, figure out the other points. So negative 1/2 x squared minus x plus 1. Starting off with negative 1. That's where our vertex has got to be. So negative 1/2 times negative 1 squared minus negative 1 plus 1. So negative 1/2 times negative 1 squared is just 1. So that's going to become negative 1/2 minus negative 1 is going to be plus 1 and plus another 1. So negative 1/2 plus 2, or 1.5, or 3/2 would be our point. So then we're at negative 1 down, or up to 1.5, so that way. Now we're going to do 0, so negative 1/2 times 0 squared minus 0 plus 1. It's just 0 plus 0 plus 1, which is 1. That's our point there, 0, 1. If we do positive 1, continuing to pick points or values of x that are to the right of that axis of symmetry. Negative 1/2 times 1 squared minus 1 plus 1. So 1 squared again is 1. So negative 1/2 times 1 is negative 1/2. Minus 1 plus 1. So minus 1 and plus 1 are going to cancel each other out. We're going to end up at negative 1/2. That gives us 2 to the right, but that's still a pretty small graph. So I'm going to go one more just to get a good idea of what the graph looks like. So we do 2, and 1/2 times 2 squared, minus 2 plus 1. So negative 1/2, 2 squared is going to be 4. Minus 2 plus 1. So negative 1/2 times 4 is going to be 2. Minus 2 plus, or I should say negative 2 minus 2, because it's negative 1/2 times 4, plus 1. So negative 4 plus 1 will be negative 3. So at 2, we're at negative 3 right here. So then we take the points we plotted to the right of the axis of symmetry, plot them to the left. So 1 to the right, so we go 1 to the left with that one. That point's 2 to the right, so we go 2 to the left. One, 2, 3 to the right, so 1, 2, 3 to the left. All right. So now it matches up on each side of the axis. Draw in our nice neat curve. And there's our parabola there. Once again, it opens downward, just like we were expecting, because it is a negative leading coefficient. All right, so that's graphing those. Now we can also use the graph to be able to solve the equation. All right, and so solving a quadratic equation using the graphs, first thing we do is write the equation in the form ax squared plus bx plus c equals 0. And then once we have that format, we graph it just like it was y equals ax squared plus bx plus c. And when we sketch the graph of the function, the solutions are going to be the x-intercepts, which, remember, the x-intercept is going to be where the graph crosses the x-axis. So whatever the x value is where we cross the x-axis is going to be a solution for the graph. And those solutions can also be called roots. So if you had a question that asked for the roots of an equation, it's the same thing as the solution. So first we got to have x squared bx and the constant on the left side, 0 to the right. So this first one we're solving, x squared plus x equals 6. So in order to graph it or to solve it, first thing we've got to do is move this 6 over. So I'm going to subtract 6 from both sides. So we have x squared plus x minus 6 equals 0. So now from there, we can figure out all the information we need to be able to graph it. First off, we need the x value of the vertex. Remember, negative b over 2a. So when we look at this, there's nothing in front of the x squared, so the a is 1, and nothing in front of the x either, so that's a 1 as well. So we're going to have negative 1 over 2 times 1, which is going to be negative 1/2, which is also where our axis of symmetry is going to be. The line x equals negative 1/2. So between 0 and 1, 0 and negative 1, our axis of symmetry is on that line somewhere. And then we're going to plot points until we can get the graph to cross the axis, cross the x-axis, because we need to know where it crosses to figure out where the solution is or where the roots are. So same process, graphing the function. So x squared plus x minus 6, starting off with negative 1/2, because that's where our axis of symmetry is, or the x value of our vertex. So plug in negative 1/2, so negative 1/2 squared plus negative 1/2 minus 6. Negative 1/2 squared, it's going to become positive 1/4. Negative plus negative 1/2, or just minus 1/2. And then minus 6. So 1/4 minus 1/2 minus 6. So we're got to get a common denominator. So using the 1/4 minus 1/2, or get that to be a 4, so we got to multiply by 2. So minus 2/4, and 6 is over 1, so multiply that 6 times 4, should be 24/4. So 1/4 minus 2/4 minus 24/4, or that's going to give us negative 25/4, which is negative 6 1/4. So just below 6, negative 6, could be where our vertex is. And so we're at 1/2, negative 1/2. So we can go to the right with points, since we're just a half of a increment to get to 0. I'm not going to plug that in there. It's quick and easy though, because everything would be 0. You'd be at negative 6, so we could put it in there, but it doesn't give us much of the graph. And so I'm going to go with 1 and 2, see if that gets me to crossing the x-axis. So 1 squared plus 1 minus 6, which is going to be 1 plus 1 minus 6, or negative 4. So I'm at 1, negative 4 there. And then 2, so 2 squared plus 2 minus 6, which would be 4 plus 2 minus 6, or 6 minus 6, which is 0. And so we're at 2, 0. So actually, that's where this graph's going to cross the x-axis on the right side, is at 2. So if we mirror those points, so 1.5 to the right, so 1.5 to the left, gives us a point there. And we're 2.5 to the right. We go 1/2, 2.5 to the left, which would give us a nice neat parabola there. But in this case, what we're focusing on is the x-intercepts, where that graph crosses the x-axis, which is at 2, and over here on the left side is at -1, 2, 3, -3. So there's our solutions there. All right, so next one, x squared plus 4x minus 12. And so we're going to get our x value of the vertex, -b over 2a. So a is 1, b is 4. So -4 over 2 times a, which is 1. -4 over 2, which is -2. Which also means that our axis of symmetry is going to be x equals -2. So on this line, x equals -2, our vertex is somewhere on that line. Make our table. X squared plus 4x minus 12 equals 0. So -2 for the axis of symmetry. That would give us -2 squared plus 4 times -2 minus 12. -2 squared is going to be 4. 4 times -2 is -8 minus 12. We get -16 for our y. So my graph's actually not big enough, so it's somewhere down here below there. Which really we're not too worried about that because we're just trying to find where the graph's going to cross the x-axis. So then we're at -2 here, so going to the right, picking points to the right, but do -1. -1 squared plus 4 times -1 minus 12. It's going to give us 1 minus 4 minus 12, or -15. So that's still way down here. 0. It's going to give us 0 squared plus 4 times 0 minus 12, or 0 minus 12, which is -12. Still really low down here. So we're going to keep going until we can cross the x-axis. So we do 1. It's going to give us 1 squared plus 4 times 1 minus 12, which will be 1 plus 4 minus 12, or 5 minus 12, which is -7, which is actually going to get us into the coordinate plane where we can see it. But it still doesn't show us where we're going to cross the x-axis. So I'm going to go on to 2. So 2 squared plus 4 times 2 minus 12 will be 2 squared, which is 4, plus 4 times 2, which is 8. So 12 minus 12 gives us 0. So at +2, we're going to intersect the x-axis, which is where we want to get to. All right. So if we mirror those 2 points that we can see, this one's 1, 2, 3 to the right, so 1, 2, 3 to the left. This one up here at 2 is 1, 2, 3, 4 to the right, so 1, 2, 3, 4 to the left to mirror it. So our graph would look something like that. Once again, what we're worried about, or what we're interested in, since we're solving using a graph. It's where we cross that x-axis. And our values there are going to be x equals positive 2 and x equals, that's negative 1, 2, 3, 4, 5, 6. 2 and negative 6 would be our solution points there. And that is how we solve using a graph.